Hi students, how are you all? I hope you are all fine and safe at home. This is K. Venkatesan from Department of Physics, Bharathidhasanar Matric Higher Secondary School, Arakkonam. Now I am going to introduce new topic, radar, from 11th standard physics, first unit, nature of physical world and measurement. Okay, see. First one, measurement of larger distance. Already we know that how to measure the distance between the two planets. Arun, say, how to measure distance between the two planets? Is it possible to measure using meter scale? Yes, impossible. So, that time we are introduced some special method adapted here, that is known as radar method. The radar method is nothing but the word radar stands for radio detection and ranging. Radio detection and ranging. So, expansion of radar. So, in this radar method is used to measure the distance of the nearest planet, which means distance of the Mars, distance of the moon from the earth. Okay. So, it is one special type of method, radar method. So, next one is the radar method to measure the distance of the any target materials, which means any target planet. How to measure the distance of the planet? See here, the radio waves are transferred from the transmitter and after reflection from the target and detected by the receiver. Okay, see, the radio waves are transferred. Here this is the source of radio waves. These radio waves are transferred from the transmitter. After the reflection of the radio waves reflected and detected by the receiver. So, here first to measure the time interval between the two events, then calculate the distance of the planet or any other target material. Okay, see. Now, I am going to determine the value of distance of the planet, which means let us consider one planet. This is the one planet, no. So, here the radio waves are transferring distance d. After the reflection from the planet, the radio waves are received by the receiver. So, here also distance d. So, d plus d equal to 2d. See, the next one is how to measure the distance between the planet. See, listen here. Speed of the radio waves. What is the general expression for speed? Is simple concept. The speed equal to distance travelled by time taken. This general expression, we know that this formula. We need only distance travelled by the radio waves. Distance of the radio wave d equal to the product of speed of the radio waves and time taken. The general expression, see here, V is nothing but speed of the radio waves, 2D is nothing but the radio waves are transferred from the transmitter after reflection from the planet received by the receiver. So, D plus D, 2D with respect to time taken. We need distance only, no. So, in this value takes out, now cross multiply V into T, so Vt divided by 2. We need D only, so Vt by 2. Is a general expression for distance of the planet. D equal to Vt by 2 is very important formula. These two formula very important formula. So, in this formula based on some NEET and IIT problem. Okay, see, listen here. See, NEET based question. A radar signal is beamed towards a planet and its echo is received 7 minutes later. If the distance between the planet and the earth is 6.3 into 10 power 10 meter, calculate the speed of the signal. Here, calculate the speed of the distance. See, my dear students, given data t, for example, what is the question? Radar signal is towards the planet. Let us consider here, this is a source of radar signal. This is a source. These radio waves are transfer from the any planet, for example any target material, so any one planet. Here the radio waves are transferred from the transmitter, and after reflection from the planet, in this radio waves are received by the receiver. Okay. So here given data means radar signal is beamed towards the planet and the echo is received timing t equal to 7 minutes. What is the value? 1 minute 60 seconds. So 7 into 60, so time is given. So t equal to 7 minutes. The next one is the distance between the planet and the earth is, for example this one is, we will take earth, this one is another planet, for example Mars. So distance between the two planets is d equal to, what is the value? 6.3 into 10 power 10 meter, 10 power 10 meter. So in this two data is given. Already we know that speed of the radio waves, see the speed of the radio waves v equal to say 2d divided by time taken. Okay, this is general expression for speed of the radio waves. Substituting this two value in above equation, we will get the answer b equal to 2 into, what is the value? Time taken with d, distance of the planet 6.3 into 10 power 10 meter divided by time taken 7 minutes, 7 into 60 seconds. So simplify this value, speed of the radio waves v equal to 2 into 6.3, what is the value? 12. Yes, 6 into 10 power 10 divided by 7 into 6, say 42, yes, 4 to 0. So simplify this value, b equal to 12.6 into 10 power 10 divided by, here rearrange 4.2 into 10 power 2, the same value only. So here 10 power 2, 10 power 10, remaining 10 power 8. See, simplify this value, we will get the answer b equal to 12.6 divided by 4.2 into 10 power 8. So 4.2, 12.6 divided 3 times. So here b equal to 3 into 10 power 8 meter per second. This is the answer. Calculate the speed of the signal. What is the value? B equal to 3 into 10 power 8 meter per second. This is the speed of the radio waves. Okay? Yes. Any doubts? Okay. The next one is see some range and other order of length, size of the object or distance and length. See, size of the proton 10 power minus 15 meter. See my students, size of the proton 10 power minus 15 meter. The next one is size of the atomic nucleus 10 power 14 meters. The next one is size of the hydrogen atom 10 power 10 meter. Length of the typical virus 10 power 8 meter. Wavelength of the light, very important, 10 power 7 meter. And size of red blood cells 10 power 5 meter. The next one is thickness of our paper 10 power 4 meter. And the height of the Mount Everest above the sea level 10 power 4 meter. Then radius of the earth is very important value 10 power 7 meter. The distance of the moon from the earth is 10 power 8 meter. Distance of the sun from the earth is 10 power 11 meter. Distance of the sun from the earth is 10 power 11 meter. Distance of the Pluto from the sun is 10 power 13 meter. Size of our galaxy 10 power 21 meter. Distance to Andromeda galaxy 10 power 22 meter. The last one is distance of the boundary of the observable universe is 10 power 26 value. So this is the long range of the or short range of the order of length. Okay, just keep your mind. The next one is see some common practical units. Same is a very important units. 1 Fermi equivalent value, 1 Fermi equal to 10 power minus 15 meter. Okay sir. 1 nano is nothing but 10 power minus 9 meter. See 10 power minus 9 meter. Next one is 1 angstrom. 1 angstrom value is nothing but 10 power minus 10 meter. 1 angstrom, in other words we are writing, see 1 angstrom equal to 10 power minus 10 meter. This is 1 angstrom value. 1 nanometer, already I told that 10 power minus 9 meter. 1 micron value, what is our 1 micron? 1 micron is nothing but 10 power minus 6 meter. Micro, in other words we are writing 1 micro value. 1 micro equal to 10 power minus 6 meter. The next one is very important 2 more questions. See my dear students, light year is a very important. Light year, what is meant by light year? This light travelled in vacuum in 1 year. This is called light year. So see, it is a very important 2 more question. You want to see this in our study material. It's very important 2 mark light year. The distance travelled by light in vacuum in 1 year is equivalent value 9.467. See, very important 1 mark. 9.467 into 10 power 15 meter is called 1 light year. Okay. So don't forget, this is a light year value. The next one is other important unit, astronomical unit. The astronomical unit, in other words we are calling 1 AU, which means 1 astronomical unit. AU is nothing but A stands for astronomical, U stands for unit. 1 astronomical unit is nothing but the mean distance of the center of the sun and center of the earth. The distance between the center of the sun and the center of the earth we are calling 1 astronomical unit. The 1 astronomical unit equivalent value 1.496 into 10 power 11 meter. This is the very important value, 1.496. See, listen, 1.496. Please keep your mind, this is very important value. 1 astronomical unit equal to 1.496 into 10 power 11 meter. Say my dear students, say Harni, what is the value of 1 astronomical unit? 1 astronomical unit 1A equal to, yes, 1.496 into 10 power 11 meter. Okay, don't forget. The next one is, this is fully constant term only. Okay, this is a measuring value. The next one is measurement of mass. Okay, how to measure any one physical quantity or derived quantity? So using some other balances, we know that the basic concept. Now I am going to measurement of mass. Mass is a properties of matter. Properties of matter. So it is independent of the, that means it does not depends on temperature, which means temperature, pressure and the location of the body. Okay, this is a 3 factor, this is a independent property. Mass is a properties of matter. Don't forget. The definition for mass is, see here, mass of a body is defined as the quantity of matter contained in a body. Say, define mass, the quantity of matter contained in a body is known as mass. The SI unit of mass is kilogram. Say, SI unit of mass is kilogram. Okay, done. The next one is range of masses. The first range, electron mass. The accurate value electron mass 10 power minus 31 kilogram. Here approximate value is given 10 power minus 30 kilogram. Okay, so mass of the electron 10 power minus 30 kilogram. Next, mass of the proton, yes, 10 power minus 27 kilogram. Mass of the neutron, sir, same value, 10 power minus 27 kilogram. Mass of the proton and the mass of the neutrons also same mass only. Okay, the next one is uranium atoms. The mass of the uranium atom is 10 power minus 25 kilogram. Okay, see, next one is the red blood cells mass 10 power minus 13 kilogram, dust particle 10 power minus 9 kilogram, raindrops, you know, raindrops, the raindrop mass 10 power minus 6 kilogram, mosquito, mass of the mosquito 10 power minus 6 kilogram, and craft 10 power minus 3, human body mass 10 power 2 kilogram, and automobile parts 10 power 3 kilogram, and aircraft range 10 power 8 kilogram, moon mass 10 power 23 kilogram, and earth, in our earth mass 10 power 25 kilogram, Milky Way galaxy 10 power 41 kilogram, and the last one is our universe, you know, observable universe 10 power 55 kilogram. This is the range of our mass. This is the microscopic range, this one is macroscopic range. It is the smallest object, this one is large object. Okay. So next one is Chandrasekhar limit. This is a very important 2 mark question. Chandrasekhar limit. The Chandrasekhar limit, in other words, we are calling 1 CSL. 1 CSL is nothing but the Chandrasekhar limit is short name CSL, is the largest practical unit of mass. Largest practical unit of mass is nothing but Chandrasekhar limit. In other words, we are calling 1 CSL. 1 CSL, which means 1 Chandrasekhar limit equal to 1.4 times mass of the sun. See, 1.4 times mass of the sun. This is called 1 CSL, Chandrasekhar limit. Please keep in mind, this is important 2 mark question or at the same time 1 mark question, this value. Okay, next one, measurement of time intervals. Already we know that last class we will see this topic, measurement of time interval. See, time flows uniformly forward. Time flows uniformly forward, said by Sir Isaac Newton. The next one is time is what a clock read, said by Albert Einstein, the great scientist, father of modern physics. The measurement of time intervals. You know, measurement of time interval. See, the clock is used to measure the time interval between 2 events, that is called measurement of time. So, olden days we are measuring time interval. How to measure? Yes, 2 ways, sun clock and sundial. This is the olden days, we are measuring the time interval between the 2 events. Nowadays we are using atomic clock, which means atomic standard of time is based on the periodic vibration of cesium 133 atoms. Say cesium 133 atoms. So see, this is nowadays we are using some of the various type of clocks. The first one is electric and electronics oscillators, which means solar clock, quartz clock, atomic clock and radioactive dating, etc. nowadays using to measure the time interval between 2 events. Okay, these are nowadays. So how to measure largest time period and the smallest time period? That means largest time period nothing but macroscopic time interval, smallest time interval nothing but microscopic time interval. See, given below tabular column, see 1 by 1. Lifespan of most unstable particle 10 power 24 seconds, minus 24 seconds. The next one is time required for light to cross a nuclear distance, 10 power 22 seconds. X-ray, period of X-ray, time period 10 power minus 19 seconds. The period of atomic vibration 10 power minus 15 seconds. The period of light wave 10 power minus 15 seconds. The lifetime of exit state of an atom 10 power minus 8 seconds. Period of radio waves 10 power minus 6 seconds. See, wings of our eye 10 power 0 second. Yes, 10 power minus 1 second. Time between successive human heartbeat 10 power 0 seconds. Time travel time for light from the moon to the earth 10 power 0 seconds. Travel time for light from the sun to the earth is 10 power 2 seconds. Time period of satellite revolving around the any one orbit, which means our satellites revolve around the any planet. The time period is, see, 10 power 4 seconds. Rotation period of earth is 10 power 5 seconds. Rotation and revolution period of moon is 10 power 6 seconds. And the revolution period of the earth is 10 power 7 seconds. Travel time for light from nearest star is 10 power 8 seconds. Average means average human lifespan is 10 power 9 seconds. Age of Egyptian pyramids 10 power 11 seconds. Time since dinosaur becomes extinct 10 power 15 seconds. Age of our universe, see, 10 power 17 seconds. So this is the range of the time interval, microscopic level and macroscopic level. See, this one is fully micro level, this one is macro level. Okay, the next one is, see, the smallest practical unit of time is 1 shake. This is very important, 1 more question, my dear students. See carefully. The smallest practical unit of time is shake. One shake is equivalent value. See 10 power minus 8 seconds. 10 power minus 8 seconds. This very important one more question. One shake is equal to 10 power minus 8 seconds. Okay. See the smallest practical unit of time is, say yes, shake. See one shake equivalent value 10 power minus 8 seconds. Okay, very good. Okay, this is our basic measurement of mass, measurement of length, measurement of time. Okay, my dear students, below this video we have attached PPT, YouTube link, study material, self assessment test question paper in this description. Thank you.